Hello everyone. It is my pleasure to welcome you all to this presentation on C, the foundation of modern programming. C is not just another programming language. It is the backbone of many technologies we use today. Developed in the early 1970s by Dennis Ritchie at Bell Labs, C has stood the test of time and remains one of the most widely used and influential languages in computer science. It has powered everything from operating systems like Linux and Windows to embedded systems and game engines. What makes C so special? Its efficiency, flexibility, and power. It gives programmers low-level access to memory while maintaining high-level programming capabilities, making it a perfect balance between hardware control and software functionality. In this presentation, we will explore the fundamentals of C, its key features, and why it continues to be relevant in the world of programming. Whether you're a beginner looking to start your coding journey or an experienced developer revisiting the roots of programming, this session will help you appreciate the beauty and power of C. So, let's dive in and discover why C remains a timeless language in the ever-evolving world of technology.
In the world of computer programming, data organization is key. Arrays are fundamental data structures that simplify this task. An array is a collection of elements, all of the same data type, stored contiguously in memory. Imagine a set of numbered boxes, each holding a single value. That's your array. Arrays excel at managing multiple data points efficiently. Need to store the ages of all students in a class? An array is your solution. Instead of juggling individual variables, you have a neat index structure to hold all the information. Why are arrays so widely used? Their power lies in their simplicity and organization. Accessing elements is straightforward. Each element has a unique index, starting from 0. This indexing system makes traversing and manipulating data within an array incredibly efficient. Whether it's storing student grades, managing inventory lists, or processing signals in scientific computing, arrays provide a structured and efficient way to handle collections of data. Their versatility and ease of use make them indispensable tools in a programmer's toolkit. Static arrays are the workhorses of the array world, reliable and straightforward. When you declare a static array, you specify its size at compile time. This size remains fixed throughout the program's execution. Declaration is simple. Specify the data type, followed by the array name and its size in square brackets. This creates an array named ages capable of storing 10 integer values. You can initialize a static array during declaration. This assigns initial values to each element. Accessing elements is done using their index, retrieves the first age, which is 25. Static arrays are allocated on the stack, a memory region with limited space. This makes them efficient for smaller datasets. However, their fixed size can be a limitation if your data needs change during runtime. Dynamic arrays bring flexibility to the table. Unlike their static counterparts, their size isn't set in stone at compile time. You determine the size during runtime, adapting to the program's needs. Dynamic arrays live on the heap, a more flexible memory space. To create one, you use pointers and memory allocation functions like, for instance, this allocates enough memory to hold num students' integer ages. Accessing elements remains similar to static arrays, using array indexing. However, dynamic arrays come with a responsibility memory management. Once you're done with a dynamic array, it's crucial to release the allocated memory using. This prevents memory leaks. The power of dynamic arrays lies in their adaptability. Need to add more data, resize the array, finish processing, free the memory. This dynamism makes them ideal for situations where data size fluctuates. When faced with a choice between static and dynamic arrays, consider your needs. Static arrays are your go-to for simplicity and efficiency when the data size is known beforehand and relatively small. Their fixed size, while a limitation in some cases, guarantees predictable memory usage. Dynamic arrays shine when flexibility is paramount. If your program deals with data that grows or shrinks during runtime, dynamic arrays provide the adaptability you need. Keep in mind the added responsibility of memory management, as improper handling can lead to memory leaks. In essence, the choice boils down to a trade-off between control and convenience. Static arrays offer control and predictability, while dynamic arrays provide convenience and flexibility. Understanding their strengths and weaknesses empowers you to choose the right tool for the job, ensuring efficient and effective data management in your C programs.